Welcome to Chapter 2. Today we're going to start 2.1, Relations and Functions. Go ahead and pause the video and get these vocab written down before hitting play and continuing on. Okay, so the first one we have is a one-to-one function. Each element of the domain pairs exactly one unique element of the range. So all the domain values have a different range value going with them. An onto function is each element of the range corresponds to an element of the domain. So every number in the range is paired with a domain value. A discrete function is one where a relation in which the domain is a set of individual points. So you can list them off and you can have them all written down. A continuous relation is a relation in which the domain has an infinite number of elements, so you would not be able to write them all down in a list. Vertical line test is the test that we use to determine if a graph of a relation is a function or not. Independent variable, that's our variable x or our domain values of a function. Dependent variable is for variable y or the range values of a function. And then function notation, it's an equation that represents a function, and we use f of x, g of x, h of x, pretty much any letter of x, and that is in function notation. We use that instead of y. Okay, so first thing we're going to talk about is one-to-one and onto functions. So the first one on the far left is a one-to-one function, but it's not onto. Okay, it's one-to-one because each element of the domain is paired with one value of the range, and none of the domain values share a range. So you see how the arrows go to a different number in the range. The reason why it's not onto is because this value in the range is not used. Okay, so that's why it is not an onto function, because one element in the range is not paired with an element of the domain. The middle one, that is an onto function, but it's not one-to-one. It's onto because if you'll notice, all of my range values have an arrow pointing to them, so all of the range values are paired with a domain value. It's not one-to-one because these two domain values share the same range. Okay, so in order to be one-to-one, they have to be different range values. And the last one is both one-to-one and onto. All of the range values are used, so it's onto, and it's one-to-one because all of the domain values go to a different range value. Okay, so to start out with, we're going to talk domain and range. We're going to state the domain and range of the relation, determine whether it's a function. That's not new. We've done that before. The new part is once we have that done, then we're going to determine if it's one-to-one, onto, both, or neither. And so we'll start with domain and range. Domain is the list of all the x values in order from smallest to largest, -6, -5, -3, -1, and 6. Our range is the list of all the y values in order, so I've got -9, -7, -1, and 7. None of my x values are the same, so that I can say that yes, it is a function. And so now for the last part here, you'll notice that I have two y values that are the same. Okay, which means I've got two domain values that go to the same range value. So that means it can't be one-to-one. Okay, and if it can't be one-to-one, it can't be both either. However, all of the range values, because the only values in the range are the ones that are listed, all of those are used. So I would say that this is an onto function. Go ahead and pause the video and do the same thing with this set of ordered pairs. So again, domain and range, decide if it's a function, and then whether it's one-to-one, onto, both, or neither. Then hit play and see how you did. Okay, so for our domain values, we've got -2, -1, and 2. Our range, we've got -2, 0, 1, and 2. This is not a function because we've got multiple domain values that are doubled up with different values. And then this is a neither because if it's not a function, it can't be a one-to-one function or an onto function. So if you don't have a function, it's automatically neither. Next thing we're talking about is the vertical line test. So how the vertical line test works, you could have a graph or a scatter plot, and basically what you do is you draw a vertical line anywhere you want in the graph. And if at any spot that vertical line touches the graph in more than one spot, you do not have a function. So these three examples on the bottom, they have one vertical line drawn in each one. So like this far left, I don't have to have it in that spot. I could draw it here, 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 anywhere I want to. And all of those lines only intersected in one spot. Same thing with the middle example. I could have any one of these be my vertical line, and they only touch in one spot. The one on the right is not a function. If you'll notice, if I start out with, it seems like it's one to start out with, and then as soon as we get here, this is where it starts to hit more than once. So that's where it is not a function. Okay, so if at any spot it hits more than once, it's not a function. So here's my first example, and I've got this line here, and I look and I see, is there anywhere where I can draw a vertical line and intersect it in more than one spot? And I draw all of these lines, and none of them intersect in more than one spot, so I can say that yes, this is in fact a function. As I said, it also works with scatter plots, so we can have this scatter plot here, and if you'll notice, if I draw vertical lines through every point, there's not one where I hit more than one scatter plot line. So this would also be a function. Here's another example. If I draw a vertical line, okay, this one right here, it hits in two spots, so I would say that this is not a function. So now we're going to talk about discrete versus continuous functions. Okay, discrete, that's a limited number of domain values. It can be shown as a table of values, a set of ordered pairs, a scatter plot, as well as others. It can be a graph as well. Basically with a graph, if you have to lift up your pencil to trace it, that means it is discrete and is not continuous. A continuous graph or a function is an infinite number of domain values. That one's usually shown with an equation or a line graph where you do not pick up your pencil when you go to trace it. Yeah, so that's the main difference between graphs of discrete and continuous. Discrete, you have to pick up your pencil. Continuous, you don't. Our first example, we've got this scatter plot. Okay? Scatter plot always means discrete because I can physically list off all of the domain values here. For this example, I've got a line graph, and if you notice, if I trace along with it, I never have to pick up my pencil. I can trace it with one stroke, so that means this is continuous. Here's another line graph. If I trace it with my pencil, I go here, and then I have to stop here, pick up my pencil, put it down up here, and then keep going. Because of this break right here, this makes it discrete. Now we're going to move on to graphing. We're going to graph the equation y is equal to 1/2 x minus 3, and then determine the domain and the range. And then after that, we're going to determine if it's a function or not, then if it's one-to-one, onto, both, or neither. Then we're going to state whether it is discrete or continuous. So no matter how you want to graph it, if you want to make your xy table, and then just pick some x values and plug them in, you can do it that way. Or if you just start with the y-intercept of -3, and your slope is up 1 and over 2 to the right, okay, we can draw our line that way. And so there would be our graph right there. Domain and range. Domain, if you'll notice, we've got an arrow going to the left and to the right, so that means our domain is all real numbers, and that's usually how we write all real numbers, is that double-stemmed R. For our range, you again look at the arrows. Okay, you got one arrow pointing downward, one arrow pointing upward. So again, we have all real numbers. And for our function, we look at the vertical line test. Okay, you draw these anywhere, you're going to notice that it only intersects once, so it is in fact a function. And for the last part, the one-to-one, onto, both, or neither, okay, if you'll notice, all of my domain values are used, and they're paired with exactly one range value. So if I plug any number in and multiply it by a half and subtract 3, I'm not going to get the same answer for two different domain values. Okay, so that's going to be a one-to-one function. For onto, all of my range values are going to be used as well because it's a continuous line. So this would be an example of both. And the last part, discrete or continuous. Hey, it's a straight line. If I drew it with my pencil, I wouldn't have to pick it up. So I would say that this is continuous. Go ahead and pause the video and give this one a try, and then hit play and see how you did. Okay, so for my domains, it's going to be all real numbers because, again, I've got arrows going both to the left and to the right. For the range, I've got arrows going upwards, but I don't have any arrows going down. And you'll notice my graph, the lowest point is at 1. So my range would be y is greater than or equal to 1. It is a function. It passes the vertical line test. It's onto, but not one-to-one. It's not one-to-one because I have multiple domain values that go to the same range. So I could plug in more than one range value, or I could plug in one range value and get more than one domain value that goes with it. And then the last one, it's continuous because, again, if I were to trace it with my pencil, I would never have to pick it up. For the last thing we're going to talk about, we're going to use function notation and evaluate a function. So we're given f of x is equal to 2x squared minus 8, and we're going to find the following, f of 6. So 6 is going to go in for x. So instead of 2x squared minus 8, I'm going to have 2 times 6 squared minus 8. 6 squared is 36, so I'm going to have 2 times 36 minus 8. 2 times 36 is 72. And then 72 minus 8 is going to be 64. So my f of 6 is 64. This is how we would write it right here. So now we can use variables in there as well, 2y. I'm still going to do the same thing. I'm going to take that 2y and plug it in for x. So instead of 2x squared minus 8, I'm going to have 2 times 2y squared minus 8. 2y squared is 4y squared, because I square 2 and I square y. 2 times 4y squared is 8y squared. And I can't combine it anymore, so f of 2y is equal to 8y squared minus 8. Go ahead and pause the video and give this one a try, and then hit play and see how you did. Okay, so the first one, when we plug in 2.8, it should be 0.5 times 2.8 squared minus 5 times 2.8 plus 3.5. And if we plug that in, we should get a negative 6.58. So g of 2.8 is negative 6.58. G of 4a, I plug 4a in for x, so 0.5 times 4a squared minus 5 times 4a plus 3.5. And I should get 8a squared minus 20a plus 3.5. So g of 4a is equal to 8a squared minus 20a plus 3.5.